At Valencell, I'm a data scientist. What the company makes is sensors, biometric sensors that go in wearables, so things like smartwatches and smart earbuds. And my team, the data science team, we take the raw signal from the sensors and create the algorithms to actually give you the heart rate and the step rate and those kind of metrics.
I am currently a software developer at ABB in the R&D department. Our team develops the software and hardware for intelligent transformer monitoring. I work on the software side, developing for both the back-end and the customer-facing software.
At Into Solutions, we do consulting with using computer-aided engineering software that allows us to simulate structural, thermal, magnetic, and airflow and cool scenarios so that people can design better products faster.
I'm a systems integrator at Rovasys. We take a company's process and their equipment, and we make that equipment execute that process. So we do everything from pharmaceutical to paper to food, anything that you can make in a factory, we want to help make that.
Yeah, the first programming I did was actually in Owen Dorm, right here on NC State campus on a Commodore 64. And then later on I took Fortran here at NC State. And to a certain extent, everything you learn in your first program that you work with applies because you're building a foundation in understanding the process, identifying a problem, making a plan on how to solve it, and then implementing it in code and learning how to test it and learning how to add comments and documentation.
When you're learning programming and programming in school, there's always an answer. In the books and the questions and the tests that you're doing and studying, there's always an answer that if you truly get stuck, you can go to your teacher or go to the back of the book and find the answer. Not everything that you set out to do is going to have an answer.
When you're working in school, you're either in 1 or 2 person groups, and the projects you work on have a specific requirement and a specific deadline, and once you submit it, you don't think about it. However, projects when I came here, where teams were larger, the scopes were a lot bigger, code was more complex. When you delivered the code, it had to be production quality, meaning you had to test thoroughly, make sure there was no case that could slip through the cracks. And then once the project was delivered, you also have to maintain the project, make sure that any bugs or issues that came up, you would go and fix those.
In school, the coding you learn is very pretty. It has that nice answer. It has a way that you're supposed to do it. In the real world, you come across these problems and it is your job to solve them. They haven't been done before. And so a lot of times you have to get creative. You have to maybe use resources, combine things that you didn't learn in school, maybe even invent a new way to do something that wasn't necessarily the cookie cutter equation that you learned during school.
Suppose you have a couple conveyors, and the upper conveyor is putting material on the lower conveyor. Well, if the lower conveyor has a problem, that upper one needs to stop, otherwise it's just going to keep creating a big mess. So now we have to think through the whole problem. What happens if there's a problem here? What happens if there's a problem here? And going through the entire sequence. In MATLAB, you can set up your breakpoints, you can run sections of code, right? That troubleshooting is really important. And the physical effect of your code, if there's a problem here, there's gonna be a bunch of people, shoveling this material off of this thing, and we're gonna be down for a couple hours.
That was another big difference that I saw coming from school to actually industry, that your code has real life consequences. So if there's an issue, that could affect an actual person, it can affect an actual machine, it can affect a whole area. I mean, in any industry, you want to make sure that what you're writing is safe and resilient. Your code's got to be thoroughly tested, it's got to fit within the requirements. And if there is an issue, you want to be quick to fix it to ensure that it keeps its safety.
We're not tied to any specific software or hardware or anything. So we've had to learn a lot of different languages. So there have been instances where I'll work on one project in Delta V and then another project with a Rockwell-based software and another project that is something absolutely new I've never even seen before. So there's constantly an opportunity to learn new languages and apply them.
I like to think of, programming languages as once you learn one, you can really learn any of them. Once you learn the basis of how coding works, knowing how programming works and how the computer thinks, from there it's just a matter of syntax and just learning the different keystrokes of the language to be able to get it to do what you want.
In this day and age, you're around a computer so much, especially if you're doing engineering design work, it's really hard to not have these basics in any language. Having these resources available to you, having the knowledge to be able to actually program a computer to automate a task is very essential, I would think.
Possibly the programs that you're going to use in your career don't even exist yet. So leverage what's available here, and it will build a foundation that will serve you well.
Gosh, if I could go back, I would have told myself honestly to learn more. I really only ever did what I needed to pass the course. If I could go back, I'd say do more with it. There's so much you can do with programming.
Obviously, study the assignment and address the assignment and do the assignment. But if there's something else that you just want to try to figure out how to write a file or export text, when you have time, go ahead and see what else the software, the programming language can do, because that type of discovery is really how you learn. You may find you like the program a lot more than you thought when you realize all the things it can do for you.
There's a lot of courses that I think, looking back now, I probably could have used programming to solve a lot of my problems or to help me more. I just didn't think that that was possible. I was kind of just going by the book and going by what my teacher told me, when in reality I wasn't using my full resources.
I really love to get those wins where there's this issue and we're not sure how to accomplish it, and then you put the pieces together and you're able to make everything work together. Code runs the world, and you can either learn code and figure out how to run it, or you can get run or have someone driving for you. Do you want to drive, or do you want to just go along for the ride?